Let's move on to the next question, right? Now, this one that goes, it comes from Fato. It's an awesome question that comes from Analytical Geometry, right? Fato, Bona Mahobi, thank you very much for sending us this particular question. So this one comes from Analytical Geometry. Let's try and read through the love letter. Remember to never, ever answer any of these questions without going through the love letter. The love letter is very key. It actually helps you with a whole lot of very exciting things. You get to see what is going on in the diagram and confirm a couple of things and then see what is given and what is not given. There's a lot of information factor that you can derive from the love letter before you even look at the question. So the statement reads as follows. It says, in the diagram, point P with coordinates -4 and 5 and point K with coordinates 0 and -3 are the end points of a diameter. So it means that this line here is a diameter. Very powerful, okay? Right, of a circle with the center M. S and R are respectively the X and the Y intercept of the tangent to the circle at point P. So we've got a tangent now. This is going to be our tangent that moves or runs from point S through point R. Okay. Right, and then we are also told that theta is the inclination of a PK, all right? We can see where theta is currently located. There's this angle here, so that's basically the angle of inclination of the line PK with the positive x-axis, right? So what's the story here? What is the story? Question 1 is asking us to determine the gradient of SR, right? We need to find the gradient of SR. Now, there are many ways of finding the gradient, and the first thing that probably comes to your mind when people ask you for the gradient is changing y over changing x. Now, when you look at the line SR, we don't really have 2 points that we can use on that line SR, the tangent, that line tangent SR. There are no 2 points that you can use in order to find the gradient. But what do we know about the relationship between a tangent and a radius? We know from Euclidean geometry that a radius or a diameter will always be perpendicular to the tangent. Now, what does that mean? Well, it means if we know the gradient of the diameter, we can then use it to find the gradient of the tangent. Why? Because the gradient of the radius or the diameter multiplied by the gradient of the tangent will always give you -1, because a tangent will always be perpendicular to a radius at a point of contact. Now, that means if I know one of them, I can use that to try and figure out what the other one is going to simply be, right? So now let's go and find the gradient of that line, which is PK, okay? So the gradient of the tangent or the radius, not the tangent yet, is going to be changing y over changing x. So I'm going to use 5 minus 3, that's going to be +3, that's changing y over, -4 minus 0, okay? This is the gradient of the radius, which is going to give us 8 divided by -4, which amounts to an answer of exactly -2. Are you happy to see a negative gradient? Yes. Why? Because your diameter is a decreasing line, so we're expecting it to produce a negative gradient. Therefore, we can then conclude that the gradient of the line SR, which happens to be the tangent, will just be +1/2, because when you multiply them, you need to get an answer of -1 since they are perpendicular to each other. Right. Let's move on to the second part of this question. We're now asked to figure out the equation of the line SR. Okay, cool. Now, how do we find the equation of a straight line? Allow me to create this space here. We're looking for the equation of the line SR, okay? Now, if you were asked to figure out the equation of a straight line, you always need 2 things. There are 2 ingredients that will help you to figure out the equation of a straight line. The first ingredient is you need a point that particular line passes through. The second ingredient is you need the gradient of that particular line that you are interested in. We just found that the gradient is going to be +1/2. Now we need a point that line passes through. If you go back to the drawing, you will see that it passes through point P with coordinates -4 and 5. There's a -4 there, and the y value is 5. So that's the coordinates of the point P. That's the point that I'm going to use in this particular case, right? So I've got a -4 and I've got 5. So I'm looking for this particular equation of a line, which happens to be the tangent that passes through point P with coordinates -4 and 5. Right? I'm sure when you're here, you guys will know what will happen. We're just going to use y is mx plus c. Okay, very simple stuff here. You're going to substitute. Your gradient is a half. That's what I'm substituting for, half. The x value there, let me put them in white. It's actually a negative form, and the y value is 5. What are we looking for? We're looking for c. You'll agree with me there. The white numbers, I'm just taking them from the point P. Those are the coordinates of the point P. Substitute for x and substitute for y. You've got 5 is -2 added with c. I'm getting a value of c equals to 7. Therefore, the equation will definitely become a half of x added with 7. So that is basically what the equation of that particular line SR is going to be. Moving on. So the next question says we need to now find the equation of the circle in the form x minus a squared plus y minus b squared is equal to r squared. Now, what do we know about these kinds of situations? Whenever anybody asks you to figure out the equation of a straight line, not a straight line, but a circle in this case, you need to know a couple of things that are very, very important, right? These are ordinary basics that we talk about every time when we work with you in classes when it comes to these stories. So for 4.1.3, we are interested in 4.1.3 and finding the equation of a circle, okay? Now, if you want to find the equation of a circle, you need to know only two things, okay? Let me just draw this circle for you. We've got this circle, which is the circle that we have at the top. I'm just interested in a couple of things here. What do we know about it? We know that if we are to find the equation, we're going to need to know what the coordinates of the center are. And that center was basically point M. So I am interested in finding the coordinates of point M, okay? But we also need to know something very important. What is that? Well, we know that there's a line that passes through here, right, which we were given the coordinates of, all right? We know that at point P, the coordinates were -4 as well as 5. We know that at point K, the coordinates were simply 0 and -3. Now, for me to find the equation of a circle, we're going to use x minus a squared plus y minus b squared is equal to r squared. Now, what do you need? You need to find the coordinates of the center because that is what always goes for A and B. So whatever the x coordinate of M and whatever the y coordinate of M, those are going to definitely be what I put for A and B in my equation. And then I'm obviously going to need to worry about the length of the radius. Once I can find how long the radius is, then I can claim that I've got my equation of a circle, which is pretty awesome. All right, so let's find the coordinates of M. M is the midpoint of those two points there. So the coordinates of M are going to be x1 plus x2 over 2, y1 plus y2 over 2. So I'm using the midpoint formula to try and figure out what the coordinates of M are going to be. So -4 added with 0 divided by 2, and then 5 added with -3 and divided by 2. So you end up with -2 as the x coordinate, and you end up with 1 as the y coordinate, because 5 minus 3 is 2. If you divide 2 and 2, you're going to end up with a 1. So that certainly means I'm now sitting with x, right, minus, which is going to give us a +2, all right, squared. This must be added with y, and then we've got here a -1, right? So those green numbers you see there are just simply coming from the coordinate of M, which is basically the center of the circle. So minus of a minus is going to give you a plus, and then a minus of 1 is going to give us a minus. Now, I'm interested in finding the value of r. So the smartest way of working with that, if you don't want to use the distance formula to calculate the length of the radius, just pick any point of interest and substitute for x and y. So I'm going to take this and sub everywhere where I see x, I'll put 0, and everywhere where I see y, I'm going to put a value of -3. So I'm going to have 0 added with 2 squared plus -3 minus 1 squared is equal to r squared, right? So you simplify all this, that's going to be 4 here, and that's 4 squared, which is 16, is r squared. So we end up with 20 as our r squared. Therefore, the equation of the circle is x plus 2 squared added with y minus 1 squared is equals to r squared, which is 20. The formula works with r squared and not r, so please be careful of that. All right. Next question, I'm going to be I'll try to be a bit quick now so that we can finish off as many of these questions as possible. We're now being asked to calculate the size of angle PKR. The size of angle PKR. Where is this angle PKR? Angle PKR, we need to locate where P is. P is there, right? Okay, we've got P, we're happy with P. So I'm going this way. I'm going from P, I'm going to K, then I'm now going up to R. So we are interested in this little angle that is lying there by point K. That's the angle that we're interested in, okay? Now, when you are here, you need to apply your knowledge of Euclidean geometry, okay? What can analytical geometry do for us? Well, first of all, analytical geometry can assist us to figure out the value of that angle, which is theta, okay? So if I zoom on that, if you just allow me to zoom on that small region there from O to where that line, the diameter cuts the x-axis, we are sitting with something that looks exactly like there's something that looks like this, right? Okay, now this is the y-axis, and this is going to be the x-axis. So where the y-axis and the x-axis intersect, that will be 90 degrees. The examiner is interested in this angle here at K. We want this angle. But if we can apply our analytical geometry skills, we can figure out the value of theta here, and then we'll be having a situation where we can say the sum of the interior angles equal to the exterior angle, using Euclidean geometry to figure out what that angle at K is. If we know theta, we're just certainly going to be able to figure out what that particular angle is going to be. All right, now what did we figure out? We did find that the gradient of that particular straight line that we worked on there, we are now dealing with 4.1.4, right? So we know that the gradient of that line PK came out as -2 from our previous calculation. Once we've got that, we are happy because we can then certainly start working out with something very, very awesome. What is that? Well, we can then go and say, okay, fine, we've got that. So we know that the gradient is always equal to the tangent of the angle of inclination. That means the tangent of the angle of inclination is equal to -2. So that means this is going to be the arctan of -2. It's going to come out as a negative angle. So I'm going to need to add 180 degrees so that it becomes an awesome, awesome positive value, which is going to be our obtuse angle in this particular case. So you're going to press second function, then you push tan, okay, open bracket. We have got -2, close bracket. When you press the equality sign, you always get a negative angle. I'm getting -63.43. Let me write that down so that we add some information in your hard drive, your mind. -63.43. -63.43 degrees must be added with 180 degrees. So we are looking for, add that to 180, you end up with an answer of 116.57, okay? So 116.57 degrees is the angle that you're getting. Why am I adding 180? Well, let's look at what is going on there. You've got a situation that looks like this. The angle 63.43, remember, according to the cast diagram, our 0 degree is here. When we count angles, we're counting anti-clockwise. That will be the positive way of looking at our angles. So if you ever get a negative angle, it means you're looking at these angles clockwise, okay? So that 43, that's 63, that 63.43 is basically an angle this side. I don't want it that side. I'm interested in finding it on the other side because I was looking for this inclination. You can see that the white angle and the yellow angle lie on a straight line, and when you add them, they must add up to 180. That is where the 180 comes in, and then eventually you're going to end up with that angle that is outside. All right, but then what are we looking at? Well, we are looking at a situation where we want to find the value of angle K, and we know that this is actually equal to 90 degrees. So I'm going to definitely say that angle theta is equals to the angle K we are looking for is equals to PKR, okay? Because there's P somewhere here and there's R somewhere there. So PKR added with 90 degrees. Why? Because the exterior angle equals the sum of the interior opposite angles. Very powerful stuff. Right. Now, once I've got the theta value of 116.57 degrees, I'm looking for PKR, okay? I can then simply finish that off by saying the angle we are interested in, that angle PKR, is just that number we have minus 90 degrees. So this answer, just subtract 90 degrees from it, then you're going to get 26.56, right? Why does it say 56? Okay, well, 26.57, not 657. 26.57 degrees becomes the total value of that particular angle that we are interested in. Okay, fine. Right, now the next question says 4.5. We have to be quick now, fast. the equation of the tangent to the circle at k in the form y is equals to mx plus c. So we want to find the equation of the tangent that is going to pass at point k, right? We want the equation of the tangent at point k. There is no such line at the present moment in my drawing. Why? Because point k is a point right there at the bottom. There is no tangent at the moment. So what I want you to know, it's a popular thing that examiners do all the time, where they start asking you about something that is not on the drawing. It is very difficult to work with something you don't see. So my advice is, if people talk about something that is not on a sketch, always put it there so that you can be able to think much more better about it. It's easy for your brain to work with what you can see instead of things that are appearing in words, okay, or imaginary stuff. So it's easier if you draw it because you can think critically about it if you see it. So I'm going to try and construct this line on my drawing, this gradient that they're talking about. So I'm going to put it, this gradient is definitely going to pass it. They said it's the equation of the tangent. If it must be a tangent, you have to keep a few things in mind. All right, let me modify it. Okay, let's just try and change that. If it must be a tangent, it will definitely have to be perpendicular to the radius. Okay, my drawing is a bit off, right? But the important thing I want you to have in your mind, right, is that this will definitely be perpendicular to the diameter, because the tangent is always perpendicular to the diameter. Very important for you to keep that in mind. Now, what does that mean? That means if it's perpendicular to the diameter, it will then mean that this line is parallel to the other tangent from the other side. And what do we know about parallel lines? We know that parallel lines have equal gradients. Since the gradient of this line, the top gradient we found of the tangent at the top was a half, since the gradient of the first tangent was a half, it definitely means even this one will also have a gradient of a half. Now, what do we know about the equation of a straight line? Well, we know that the equation of a straight line is given by y equals to mx plus c, where m is a gradient. I'm going to use half as my gradient. That's going to be half x. Now, c is the y-intercept of the line. And guess what? We are given that this circle at point k cuts the y-axis at -3. That means the tangent is also going to pass at y is -3, which makes our c value to become -3. So the equation of that tangent that passes at point K will then be half x minus 3. Absolutely awesome question. All right. Now, in closing, we'll close with 4.2. Let's go to 4.2. Now, 4.2 says we need to determine the value of t such that the line y is half x plus t cuts the circle at 2 different points. So we want the line that is going to cut the circle at 2 different points. That will have that equation y is half x plus t. All right, let's look at that. Let's look at it away from everybody else. So what are we sitting with so far? Well, so far we've got a circle. Very important for you guys to analyze this. And always remember that these questions are basically relying on what you have done up to so far. Okay, what do we have so far? Well, we know we found the tangent. One tangent at the top, okay? This is the first tangent that we found. And then there's another tangent at the bottom, which I'm going to use a different color for. Let me put it here. So this is basically what we have, right? So now the first equation of the tangent that we have at the top was y is equals to half of x plus 7. The other tangent had an equation of y is equals to half x minus 3. Now, the examiner says they want you to find the equation of a straight line that will have the equation y is equals to half x plus some number t. Now, we don't know what t is. We're asking you to tell us what are legal t values that we can use. What are the legal t values that we can use such that this line will cut the circle in 2 different places. We wanted to cut it in 2 different places. Now, what do you notice about this? Well, you notice that the top tangent touches the circle at 1 point. So this would not be the ideal case of what we are interested in, right? And the other thing that I want to draw your attention to is the gradient of the top tangent is a half. The gradient of the bottom tangent is a half. And the gradient of the line they want us to talk about is also a half. That means the line we are interested in also has to be parallel to the lines that we have already drawn here in our question, okay? We're already going to definitely work with something that looks like that. All right, so let me draw it in blue as well. So we want the second blue line. This is the line that we're interested in. We want to find the equation of that line. So we want to know what are the legal t values that you guys can work with. All right, so if you may allow me to just change the color of this one. Let's make this one white. We're going to call this one the white gradient tangent so that we don't confuse it with the line that I want to move around. Right. Now, the line that I want to move around, I'm going to actually touch on it. This line, if it's there where it is now, on top of the white line, it will have the equation of half x plus 7, right? Now, think about it. It's going to have the equation of half x plus 7. If you shift it down, the value of 7 changes. If I move it down 1 unit, 7 is going to be 6 because you have dropped the graph down by 1. If I move it from half x plus 7 by 2 units down, it's going to go 6, 5. So its equation is going to be half x plus 5. So the more you decrease it, the more the t value changes from 7 and becomes smaller and smaller and smaller. The graph is shifting down, cutting the circle in 2 places, right? So now let's go back to it, the blue line. I'm interested in the blue line. So the blue line, I want to move the blue line, not the white line, the blue one. Let's go back to the one. So I want to move it down. It must go down, 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 cutting the circle in 2 places, cutting the circle in 2 places, cutting the circle in 2 places until it gets to the yellow tangent. Because at the yellow tangent, it's now going to touch the circle at 1 point, and any further decrease will no longer cut the circle. So the only legal t values that you can have on this line, right? The only legal t values that you can play with when it comes to this particular line of y is equals to half x plus t. You need to see that t cannot be more than 7, because if it's more than 7, then your line will be above the top tangent. And t cannot be smaller than -3, because if it's smaller than -3, it is now going to create a tangent that is, a straight line that is going to be below the yellow tangent. So the only acceptable t values that you can work with is t can be anything. T can be anything between -3 and 7. It must be a number smaller than 7, but bigger than -3. Because once it gets to 7, it becomes a tangent. And when it gets to -3, it becomes a tangent as well. Anything beyond those points is going to put us in a position where we no longer have a line that touches our circle.